This is a continuation of a problem that we just did. We are looking at a confidence interval now because this here we're testing the claim by constructing an appropriate confidence interval. So we just did a hypothesis test on two proportions, and a proportion 1 for over 55 and a proportion 2 for under 25. Now we want to find a confidence interval between them. So the confidence interval we want is going to be at the 0.01 significance level. So this is a proportion problem. So what we can do is we can think about this as wanting to know if our our data, our test statistic, is going to be in the failing to reject region, which is here in the middle, or further out, outside of these bounds. So this is 0 over here, and what we're interested in doing is constructing a confidence interval here to find the difference between P1 and P2. And depending on where our confidence interval is, if it's going to include the 0, then we could be within this boundary. If it's not going to include 0, then we're going to be out of that boundary. And what we need to do is we need to, at the 0.01 significance level, this is technically a one-tailed test. When we did the hypothesis test, we saw that this is a right-tailed test because we're assuming that the first proportion is bigger than the second proportion. So what we want is we want one of these tails to be 0.01, which means the other side is 0.01, and we have the middle at 98%. So this is our confidence interval for the test. So let's construct our confidence interval. This is our proportion test we just did. Let's go to stat, test, and let's scroll down until we see the interval command that we want, and that is going to be the 2 prop z test. So let's select that. Since we had just run the hypothesis test, we see that all our data is still in there, and we just want to make sure that our confidence level is set at the right level, and that's 0.98. Looks like it was already set, and let's hit calculate. Before we do that, let's take a quick picture and put our data there. Let's go back to our calculator and let's run this, and let's see. So here's our confidence interval. Now what I want you to write in a test situation, if I'm asking for a confidence interval, is a calculator command, which is 2 prop z int. So it's an interval using the z distribution for 2 proportions. And then instead of just writing these parentheses, I'd be okay with that, but I'd rather have you actually write down the values using this notation. So you have the lower limit, and an upper limit would be up here. And then what's important to use this notation because the symbol in the middle tells me that you know what parameter you're finding the confidence interval for. So here the parameter is not just a p or a mu, but actually it's a difference between 2 proportions. So it's p1 minus p2. Okay? So this is your confidence interval. And what you need to do from here is to write down what this means. And what this means is that your confidence interval is going to be, let's see if we can do this in a different color, is going to be on the positive side. Your confidence interval is going to be somewhere over here. And what's important to note here is that that confidence interval does not contain 0. So in words, what you can do is you can describe your conclusion by saying since The confidence interval does not contain 0, there is a significant difference between the two populations. And the two populations are over 55, has a larger proportion than the under 25 group. Okay, so the over 55 over here is the first population, and the first population minus second population yields a confidence interval that's positive. So this is positive, so it weighs more on the positive side on the first expression over here. And this should be the same result as we've gotten from the previous problem that we did when we used the actual hypothesis test. We saw that it does support, the data does support the fact that there's more people over the age of 55 who dream in black and white than the people under the age of 25. All right. Okay, hope that helps.